Wave 51 deals with trying to find out which one of any kind of bond is the most polar. And to do that, you have to calculate the difference in electronegativity between the two atoms bonding in question. And for this, you're going to use table S. So for example, if we want to calculate the polarity between hydrogen and lithium, for example, we would take the electronegativity difference of the greater from the smaller. So to do that, you can also remember that anytime you need to evaluate the electronegativity of an element, you can use this electronegativity trend. So remember, elements toward the top right-hand corner are going to have greater electronegativities from elements to the left and bottom. So for example, oxygen and fluorine should have a small electronegativity difference compared to carbon and fluorine. The reason being is fluorine is most toward the top right and carbon is most to the left. So it would make sense that carbon has a lesser electronegativity than, say, oxygen. So the difference should also be greater between carbon and fluorine. So let's use this idea to answer some Regents questions. Which bond is most polar? Please note that oxygen is in this corner, and we're comparing the electronegativity values to oxygen if we want to find out which bond is most polar. Note that carbon is here, hydrogen is all the way to the left and the top left, nitrogen is here, and sulfur is at the bottom. So note that the distance between oxygen on the periodic table and hydrogen is the greatest. So oxygen would be the most electronegative atom in this case, and hydrogen would be the least electronegative atom, primarily because it's more toward the left. So your answer should be 2. Note that you could also have used table S to find out the electronegativity values of every single one of these atoms, and then just calculate the difference. The one that is most polar is going to be the one with the greatest difference. So answer choice 2 is correct. Which pair of atoms has the most polar bond? To assess the polarity of a bond, all we have to do is calculate the electronegativity difference, and when you do, you'll find that the greatest difference will result in answer choice 2, HCl. Alternatively, note that Cl is here and H is all the way over here. So when you're comparing the difference in electronegativities, you could just use the trend on the electronegativity. You could use the trend of electronegativity on the periodic table. Note that if you're comparing I and Br and I and Cl, here is I, here is Cl, and here's I and Br, and they're relatively close to each other compared to H and Cl on the periodic table. H is all the way over here, Cl is all the way over here, and note that Cl is closer to the top right-hand corner, so it should possess the greater electronegativity compared to hydrogen. Next problem. Which formula represents a molecule with the most polar bond? Looking at the electronegativity values for each one of these elements will reveal that the greatest difference results in choice 4. Alternatively, you can note that here is Cl and here is H. Notice the distance between H and Cl compared to C and O and N and O. So it makes sense that 2 and 1 should have a lower electronegativity difference compared to choices 3 and 4. Now you have to decide between 3 and 4. Well, you're comparing the difference between H and I and H and Cl. Well, which one of these has a greater electronegativity, Cl or I? You should conclude that Cl has a greater electronegativity because it's more closer to the top right-hand corner. Therefore, the difference in electronegativity will be greatest between H and Cl. Alternatively, if you remember that atomic radius tends to decrease when you're at the top right-hand corner, you'll note that Cl, because it is more toward the top right, has a smaller radius compared to iodine. So it makes sense that the distance between H and Cl is smaller compared to H and I. Therefore, Cl is going to be closer to H compared to I and H. So Cl is pulling the electrons of H closer toward it and with more force because the distance between these two atoms is smaller compared with that of Hi, which has a much larger radius. Therefore, there's going to be more polarity present in this molecule compared to this molecule. Next problem. Explain in terms of electronegativity differences why CO bond is more polar than a CH bond. Looking at the electronegativity values of HC and O, they are here. You'll find that CO bond is more polar simply because the difference is 0.8 compared to CH bond, which has a difference of 0.4. Here we have 3.4 minus 2.6 between C and O, and here we have 2.6 minus 2.2, which will give you 0.4. The bond between which two atoms has the greatest degree of polarity? Using table S will reveal that H and O indeed have the greatest degree of polarity because the difference in electronegativity is highest. The bond between which two atoms is most polar? The easiest way to reveal the answer is to look up the electronegativity values, calculate the difference, and you'll find that I and F indeed have the greatest electronegativity. Which statement explains why a CO bond is more polar than an FO bond? When assessing polarity, you have to calculate electronegativity difference, so answer choice 3 is correct. So when it comes to assessing the polarity, the degree of polarity between two atoms, you have to look at the electronegativity difference. The greatest difference will result in the greater degree of polarity because one of those atoms is pulling electrons closer toward it compared to the other. And you can always look up the electronegativity values on table S. Thank you for watching.